Can I say now?
Hello.
Uh,
Hello, ma'am. Yeah, am I audible to you people now?
Yes, ma'am.
yes, ma'am.
Okay.
Hello, ma'am.
Yeah.
Ma'am, I am saying that suppose x square minus 1 equal to 0
Okay.
and minus x square plus 1 equal to 0.
Okay.
Is it same equation, ma'am?
Yeah, the equations are same only, and they're considered to be the roots are same, but they'll consider if you compare them to this, then they'll be considered different. But it's like this: if you take x square minus 1 or 2x square minus 2, so the coefficients are different. That way, the equations are different, but the roots are same.
So the equation are different.
What if you will consider them as polynomials? They're different. Equations would essentially be same, right? Because what
No, ma'am,
if
I
you
am
look
trying to say about in week 3 quadratic equation only.
okay, what's the
So is it,
question?
I think you can multiply both sides by -1. And 0 into -1 would be still 0. So you can change the signs that way, I think.
What's the question?
No, about the same question that
No, I'm asking the person who asked the question. What is the question about?
hello, ma'am, can you hear
Yeah,
me?
yes.
Ma'am, the question is uh, about the a statement. If two different quadratic equations
Okay,
have the same discriminant,
okay.
then the roots of both equation can be same.
So two quadratic equations with same discriminant. and it's about whether roots can be same.
Then the roots of both equation can be the same.
Yeah, they can be same. They're not always same, but they can be same. If it says can be same, then it should be correct. Is that
But
okay?
ma'am, they are a sir taking class like this, it can't be same, never. Because the if only the case is for the equivalent quadratic equation, like I gave you the example, for that
Yeah,
case only it will be same, but it is the same equation. You like you
yeah.
subtract, multiply or divide something.
You have this, right? And then you have 2a here. So you're saying that if your discriminant is same, let's say b square minus 4ac by 2a. This is a different thing, and then you have here minus b by 2a. So let's take, for the discriminant thing, you need b square minus 4a. Okay. It involves two things here, right? Minus b and a. It involves b and a both. And your b and a, let's say this thing turns out to be the same for both equations, this entire thing, right? B square minus 4ac. Let's denote one by capital and the other one by small. And then we have b square minus 4ac by 2a. So this will be, these two things are same. And it's automatically, it says that the discriminants are same. That means these two things are same. So your 1 by 2a and 1 by 2a has to be same. So a and a has to be same if you're taking these two things. Okay. Let's drop this too, and let's take this here. Minus b by 2a plus minus square root of b square minus 4ac by 2a. Now, this says if your discriminant is same, you will have, let's divide both sides by this discriminant. You will have minus b. Okay, you'll be left with discriminant anyway.
I have a suggestion. Just take
Yeah.
a simple case of when b square minus 4ac becomes 0. So say you take x minus 2 the whole square and x minus 1 the whole square, because you have repeated roots. The discriminant is going to be
Yeah.
0. That means the discriminants are equal, but the roots need not be equal.
Yeah, the roots are not equal, but we need a case where there are two different quadratic equations. What you have done is you have taken two different quadratic equations with same discriminant where roots are not equal. But the question is, can they ever be same? Is there a case where they can be same? For that, you either need to prove that they never can be same, or you need to have an example where they're same.
Ma'am, is this doubt clearing session or a revision session?
This is a revision session. We'll take this doubt towards the end because it's going to take time, and we're not left with much. We have a lot to revise. So let's revise things first, and then we'll take up this question. Is that okay?
Okay.
Okay. So,
Excuse me, ma'am.
yes,
Ma'am, are we going to revise all the 4 weeks, ma'am?
yes.
Ma'am, like mostly we are having doubt in 3rd and 4th week, ma'am, not in.
Ma'am, excuse me.
You had doubt, just 1 second. You've had sessions for week 3 and 4, right?
Uh, yes, ma'am. My week 1 and 2 is almost clear, ma'am.
Then why didn't you bring up your doubts in those sessions?
Not like
I can't
doubt,
hear
ma'am,
you.
but I want to
Your voice is not clear. Yeah. This session was supposed to be, because we have a lot to revise from week 1 to 4. You might have everything clear from week 1 to 2, but other people might have some doubts, might have some problems from there as well, right?
Yes, ma'am.
Hello, ma'am.
Okay, ma'am.
Ma'am, can you reverse the order?
No, we are going from 1 to 4. Okay. So just give me a minute. We'll go from week 1 to 4. That way only you will be able to connect things. Otherwise, if we start from everything will get messy. That's why we'll start from week 1 and then we'll go. Please, we'll quickly go through there'll be a very quick recap of weeks. We're not going through the entire summary of each week. So first is yeah.
Set.
So first is a set, and we're not discussing the definitions and all of sets. What is a set? What is a subset? And then all of that. So we're starting directly from Cartesian products. Cartesian products are basically, if you have two sets A and B, then the Cartesian product of the two sets A, B is where it's a tuple where first element in this tuple, first element here is coming from A, and the second one is coming from B.
Ma'am, a little slow.
This is from A. What?
A little slow, I said.
Okay. So this is the Cartesian product, is where you take the cross product. This is cross product or Cartesian product, whatever, of two sets is basically you have a set A, a set B. Let's say your A is this, A1, A2, and so on till AN. Then you have B, where B is B1, B2, and so on till Bm. Or because you want to have a Cartesian product. So if this is it, that this means that it's the collection of all the elements. Your A cross B is the collection of all the elements of A, B type, A comma B, where your A is coming small a. This first element is coming from this A set, and the second element of this tuple is coming from the B set. This is it. This is your Cartesian product. So the total number of elements here would be, here you have n number of choices, here you have m number of choices. So the total number of elements will be n into n. Okay. Then coming to relations. So relations are always defined on a set. First things first. So relations are defined on a set, and let's call that set A. Let's say A. So that means your relation is the subset of the Cartesian product A cross A. So if this is a relation and you're defining a relation on A, that means R, that relation is a subset of A cross A. So let's say you have A, your set is 1, 2. Then A cross A is 1, 1, 1, 2, and 2, 1, and 2, 2, right? That's it. So this is your A cross A. Then every relation on A is going to be a subset of this set, this entire A cross A. That's what's first thing. And what is a relation? It's basically take one element from A and the other element from A as well. That's the idea of relation. Is that okay? So let's say you have to define a relation on this set, then your relation could be 1, 1, 2, 1. This is a relation on set A. This is it. Then we have types of relations. So the first relation that we have is reflexive. These are the basic ones that you need to know. So reflexive is basically when you have, let's say, R defined on A, where A is the set, this is the relation. So this R would be called a reflexive relation if for all A belonging to the set A comma A belongs to R. So that means, let's say your set is 1, 2, 3, and you have to define a relation, a reflexive relation on this, and you have to define a relation which is reflexive. Then what you need to do is you'll have to define it in a manner such that you have a 1 here. So we need a 1, 1 here. You have a 2 here,
2,
so we need a
2.
2, 2 here, and then 3, so you need a 3, 3 here. That's your reflexive relation.
Excuse me, ma'am.
Yes.
Can only 1, 1 and 2, 2 of set will be reflexive?
No, if you've been given this set and then you're saying this relation R is equals to 1, 1 and 2, 2, this is not a reflexive relation on this one, on this set. But if you change your set and let's say you're saying I'm taking the set to be 1, 2, then it's reflexive here. Is that okay? Okay. So then the other one is symmetric. So symmetric is, we say R is symmetric on A or you're saying a relation is defined on set A, and then how you have to check is every element from the set should have. So if 1 is there, if A is in the set, this is the symbol for all. That means for every element in A, your A comma A pair should be in your relation. That's when it's called reflexive. For symmetric, you'll need for all AB belonging to the relation, you'll need B comma A in the relation. That means if you have a pair, or if this confuses you, you should write if AB belongs to your relation, then BA should be there in the relation. That means if this is the same set, if I'm taking the same set 1, 2, 3, then my A, and let's say I have to define a symmetric relation this time. So if I'm taking 1, 3, then I need to make sure that 3, 1 is also there. Only if 1, 3 is there, then is when you have to make sure that 3, 1 is there. So if this is the hypothesis, if this is satisfied, if A comma B is in R, then B comma A must be in R. That's your symmetric relation. Is that okay? And then third, you have transitive. So for transitive, you need.
Ma'am, that's true for only one pair, right? Even for one pair.
Yeah, this one is a symmetric relation on A. If you have more than that, let's say if you have 1, 2 here, you need it to be true for every pair. This means whenever A comma B, and A comma B is an arbitrary element in relation, right? So whenever you have a pair that looks like A comma B in your relation, then B comma A should be in R. Like in this one, 1, 3 is in the relation. So 3, 1 should be there. 1, 2 is there. So 2, 1 should be there. If it's not there, then this is not symmetric.
Excuse me, ma'am.
Yes.
Ma'am, then what's the difference between identity relation and reflexive relation?
Identity relation is basically, when you have an identity relation, it's basically, okay. Identity on A means, or identity relation on A means, here I'll write it so you can spot the difference. Let's say you have to define R on A. So this will be an identity relation if this only should have, let's say A is 1, 2, 3. To make things simpler, let's take A to be 1, 2, 3. Then your identity relation is just this 1, 1, 2, 2, 3, 3. Now, is an identity relation a reflexive relation? Yes. Is every reflexive relation an identity relation? No. This is an identity relation. Now look at this relation 1, 1, 2, 2, 3, 3, and 3, 2. Now this is a reflexive relation, but it's not an identity relation. That's the difference. This is reflexive. This is identity and reflexive both. Is that okay?
Okay, ma'am, clear.
Okay. Moving on. We were on transitive relation. So
Excuse me, ma'am.
yes.
Basically, it means that there can be extra pairs in a reflexive relation, but there cannot
Yes.
be. Okay, okay.
Okay. So now you have A comma B, B comma C belonging to your relation, let's say. Then you would need, so whenever I should write whenever. So whenever you have two tuples or two pairs, AB and BC belonging to R, then this should imply this when I've written whenever, so you know the importance that whenever two pairs are there with the second element and first element common, so if the second element of this and first element of this are common, then AC should be in R whenever this thing is happening. If 1 2 is there, 2 1 is there, then 1 1 should be in the relation. If 1 2 is there, 2 4 is there, then 1 4 should be in the relation. Okay. This should hold for every element. So let's say you have the same set A and you're defining a relation here. Then you'll have, let's say you have 1 3, then 3 2. Then to make this transitive, you will need 1 2 pair here, right? And let's say you have, so this you can consider this is a transitive relation because the second element of this, first element of this are common. So you need 1 2 in the list. And the second element of this is not common with the first element any other pair. So you don't need to check anything. Second element of this is not common with the first element of any of these. So you don't have to check anything. Is that okay?
Ma'am,
Yeah.
ma'am, there is a question about antisymmetric in EPA. Can you explain little bit?
Yeah. Just tell me which question it is.
Can you explain the antisymmetric relationship?
Ma'am,
Yeah,
one
just 1
general
second.
question.
Yeah. Yes.
I am telling that for in term, the graded assignment of 7 week out of the 12 week will be considered, right?
What?
For
Any doubts? Yeah. Are doubts regarding these things, GA and all? What's your doubt again?
yeah, GA.
It's regarding GA, right?
Yeah, not the question, but I am asking about the eligibility.
Yeah, we'll discuss that later. And this is a revision session and we have a lot of questions to do, lot of theory to revise. So I need you guys to understand that we don't have a lot of time to discuss everything here, right? So if anything regarding the course and how things are calculated, how marks are calculated, we can take those questions up towards the end of the session, at the end of the session. Is that okay?
Yes, ma'am.
Ma'am, the antisymmetric, can you?
Yeah. So the anti-symmetric one, let's say you have R on A and you have AB belonging to A, such that your A, or let's say, so this one, okay, let me just write it more precisely. This one says that if your AB and BA, let's say if both of these relations are related, like if both of these pairs are in R, or equivalently you can say under R, A is related to B and B is related to A, then this should mean that A and B are same. So that's your anti-symmetric relation. That means the only time you'll have both of these same, okay. Let's say when you have a relation A, when you have AA in the relation, what does this mean? This means if you have, let's say, that's why it's called anti-symmetric. That means if you have AB and A and B are different, A not equals to B. In other words, or you can phrase this as if AB is in R such that A and B are not equal, this means BA should not be in R. Is that okay?
Yes.
So you can use
I
either
can't
definition.
understand it.
You don't understand this?
Ma'am, my way
Ma'am,
of
can
looking at
you
it is if
do it
AB belongs
example,
to R,
please?
if AB belongs to R and BA also belongs to R, And if A is equal to B, then it's an antisymmetric relation, right, ma'am? That's all it
Yeah.
is.
These two things are essentially the same things, just put in different words. That's it. Because
Ma'am,
this
can
is
you give me example,
Ma'am,
please?
so ma'am, what is the
Okay.
difference between anti-symmetric relation and symmetric relation?
You will see the difference from here. What does symmetric relation says? It says if your AB is in the relation, then I want BA to be in the relation, right? This is what symmetric means. But anti-symmetric means, as the name suggests, it's not in favor of symmetry. So it says that if AB is in the relation, then BA should not be in the relation. That's what it says. This is anti-symmetric relationship. But there's
Okay, ma'am,
a
understood.
caveat here, which is if A is not equal, let's say if your A and B are equal, then your pair would be, this pair would become AA. And then I can't say that AA should not be in R. This is a contradiction, right? If I'm saying AA is in R and AA is not in R, this is a contradiction. That's why I mentioned here that A should not be equal to B. So this is because it's easier to learn, you see. Symmetric relation is AB. If AB is in the relation, BA should be in the relation. Anti-symmetric relation is if AB is in the relation, BA should not be in the relation provided A and B are not equal. That means when A and B are not equal, for every pair AB, BA should not be in the relation. Is that okay?
Got it.
Okay.
Yeah, ma'am.
Okay.
Ma'am, I have a
Then,
doubt.
yeah. Yes.
Ma'am, the odd and even function
Okay.
is not taught by the prof, but it is in the extra practice assignment of week 1. Can we find any question regarding this in the quiz 1?
Odd and even functions, I don't think you will. Okay, you won't be given. I'll just tell what you know what odd and even functions are, right?
Yes, I
The
know that,
only
but
thing, okay, there can be questions from there, but there's a very little possibility that they won't give you the definition if it's not mentioned in the course itself. Then you're going to get the definition of what an odd function is and what an even function is if it's used in your question. But that doesn't, if it's not in your syllabus, that doesn't mean they cannot ask questions on that. You can be asked question on that, but you will be given the definition if it's not
okay.
explicitly given in your syllabus. Okay. Okay. So then
Hello,
we
ma'am.
have, yes.
So can we say if a relation is not symmetric, we can say it is antisymmetric?
Okay, let's say if you're saying if there is a relation, then can we say that there are only two possibilities, either it is symmetric or it is anti-symmetric, right?
Yes, ma'am.
Is that what you're saying? So the answer is no. There could be a relation which is not symmetric and it's not anti-symmetric either. And how is that possible? Let's take a set. Let's take A is equals to 1, 2, 3. And our aim is to find a relation on this set such that it's not symmetric and it's not anti-symmetric. So let's take 1, 2 and 1, 3 here. Then for this to be symmetric, I need the reverse of each pair, right? So I'll need 2, 1 here. Let's keep 2, 1, but I'm not keeping 3, 1. So if you look at this relation, this is not a symmetric relation, right?
Yes, ma'am.
This is not a symmetric relation because 1, 3 is there, 3, 1 is not there. This is not an anti-symmetric relation either because 1, 2 is here. And this says if 1, 2 is here, then 2, 1 should not have been here, right? For this to be anti-symmetric. That means this relation is neither anti-symmetric nor symmetric. Is that okay?
Okay, ma'am.
Ma'am, please give the example of anti-symmetric relation.
Let's define one relation here. Let's say you have, this is an example of anti-symmetric. Just 1 second. Okay. This is not an example, right? We have taken this 2, 1 here. Let's take 1, 2 and 1, 3. Now this is a relation on this set, right? And this is anti-symmetric. Why? Because we have 1, 2, but we don't have 2, 1. We have 1, 3 and we don't have 3, 1, right?
Okay, ma'am.
And this is 1, 1. If I'll add 1, 1 to this set, it's still anti-symmetric. Is that okay?
Are you sure 1 to 1, 3 relation is anti-symmetric, ma'am? Because the definition says if A comma B belongs to R and B comma A also belongs to R, this can only happen when A equal to B. In this case, it is anti-symmetric or asymmetric?
It's anti-symmetric, right?
Is there any term called asymmetry?
Yeah, should we discuss that too here? Asymmetry, I don't think you have questions on that. Do we have questions on that?
No, there are no questions on
No,
asymmetry.
So you don't need the definition then. You can forget about asymmetry. But this one is anti-symmetric. The anti-symmetric definition says, that's why I tell you to remember this definition, that if AB is in R, BA should not be in R, provided A and B are not equal. Now look at this pair. Let's come to the first pair. This is 1, 2. This looks like this, where A and B are not equal. 1 and 2 are not equal. So BA should not be in R, which is true, right? 2, 1 is not here. Same goes for 1, 3. And 1, 1, you don't need to test for 1, 1 because 1, 1 is not this kind of element. 1, 1 is not the AB kind of element where A and B are not equal. These two are equal, right? Is that okay?
Okay,
Yes,
ma'am.
Okay. So then moving on to the
Excuse me,
next.
ma'am.
Yes. Yes.
I have a doubt. If R is equal to 1, 1, then is the relation is anti-symmetric and identity?
1,
No,
1. What's the
anti-symmetric
set?
is and
If R is 1, 1, what is A? Relations are defined on a set, right? What's A?
Let it be 1 alone, ma'am.
1 alone, then this is identity. That's correct.
It's anti-symmetric
If A
also.
contain,
Yeah.
if A
If A-
contain another element,
then it's not identity. And this is not
okay.
identity, but it's still anti-symmetric. This is anti-symmetric either way.
Okay, ma'am. Thank you, ma'am.
Okay.
now how it is anti-symmetric? Because A equal to B.
Yeah, that's why for A equals to B elements, you don't need to test the hypothesis. This is the hypothesis, right? So you don't have to test this. If your A and B are if they're equal, you have to test this thing. You have to go to this step only if your A and B are not equal. And in this case, they are equal. That's why you don't check it at all. And you can directly say, for these type of elements, you can directly say 2, 2, you can directly say this is anti-symmetric. Okay. Then coming to functions. Your
One
functions
question,
are,
sorry.
Yes.
One question I had, ma'am. So, given a set, the identity relation will be the minimum number of elements to make that as a equivalence relation. Is it correct?
the minimum number of elements that an equivalence relation on that set have.
Yeah,
That
it
can
will be the identity relation, right, ma'am?
that will
Because
be the
say
identity relation.
because I think symmetric and transitive are vacuously true, and anyway you have the reflexive elements.
Yes, that's correct.
Thank
you. Okay. So let's come to functions now. Your functions are basically a type of relations, special type of relations where okay. So it's like this. Let's say you have A1, B1, A2, B2. These type of elements there. Or let's say, okay. So your set of functions is contained in set of relations, and your set of relations is contained in the Cartesian product, right? A cross B, where let's say this is what you take as domain and this is what you take as, or let's just not define it this way. But you should know that functions are a collection of functions is a subset of collection of relations. That functions are special type of relations. So let's define a function. It's there's one set called domain, and there's one called codomain, where your This is considered, you can look at this as an input set that your function takes. So you will have your input here and then you will get an output. So this is your output set. So this is not equal to the output set. It's basically what you will get as an output should be in your codomain. So let's say if you have a function and your conditions are that if you have f the diagram would be a nice approach. So let's say you have 3 elements or 4 elements here and you have 2 elements or let's say 4 elements here. Then your idea is, let's say this is A set and this is B set, right? And let's call this A1, A2, A3, A4, and this as B1, B2, B3, B4. And a function is basically where you have to have one image for every element and only one image for every element. That means this should not have 2 images. This should not happen that it has, these are called images, right? So this B, if this is happening, then B1 is called the image of A1. That's the definition of image. And if A1 has one image B1, then it should not have another image. So one element should not be going to 2 elements here. That's one thing that you have to look out for. And then the other one is that if you have a mapping, let's say this thing, this thing, this thing, then every element should have at least one image. That means every element should have something to pair up with in the B set, and no element should have 2 elements from B to pair up with. That means A1, if is with B1, then A1 cannot be with B2. Now, if you will collect these elements, let's say if this is it, then this is a relation, right? This is relation on, if you're taking, this is a relation because it's a subset of A cross B. Or let's take, you can define your relations on A cross B. They can be subsets of A cross B as well, right? That's also fine. Earlier, I've said this is a subset of A cross A, but we can say if it's defined on A, if the relations to be subset of A cross B, where A and B could be different sets or they could be same sets as well. And in all of these cases, we've taken them to be same sets. So here, if you will have things, or let's say you have defined R as this, then this is, why is this not a function? Because A1 is going to 2 elements. A1 is mapped to B1 as well, and it's mapped to B2 as well. And this should not happen. That's why this is not a function. And let's say if I remove this thing, if instead I take 2 here, then again, it's not a function because you do not have the image of A3 and A4, right? So that's why this is not a function. Because a pair starting with A3 to make sure that A3 has an image, and a pair starting with A4 to make sure that A4 has an image is not there. That's why it's not a function. Is that okay? For example, you can take y is equals to plus minus root x. Now, if you have this thing, or let's call it fx. If you have fx is equals to plus minus root x, then this is not a function.
Yes, ma'am.
Because it can take 2 values. And then again, the other properties, this is 2 value property that it's violating. And then other is, let's say this. Where you have f defined from R. Let's say this is it. This is real numbers and this is also real numbers. So if you have defined a function from R to R and you're saying your function is fx is equals to root x, then this is again not a function, right? Not a function because your input cannot be -1, but -1 is in the set of real numbers, right?
Excuse me,
That
ma'am.
means, yes.
If many elements have the same image, then it is a function or not?
If many elements like these many elements have the same image, then it's a function. This is a function, that's fine. You can have a lot of elements mapped to the same element, that's fine. But you cannot have one element mapped to 2 elements or more than 2 elements.
Function, right, ma'am?
Yeah, many to
Okay,
one
ma'am.
function, or you call it not 1, 1.
Okay, ma'am.
Okay. So this is again not a function. Now coming to the domain and codomain part. So for the domain one, your domain is this set where the input set is called the domain set. So the values this set, this is called your domain set. This entire A is domain. And let's say that this is your function. Let's say this is a function, right?
Yes,
Is this
ma'am.
a function? This is a function, right? So this A is your domain. And what's the codomain here? This B set is called your codomain. And then the range is this.
B1,
Let's
B2,
remove
B3.
this. Your range is B1, B2, B3. Range is basically the collection of all the values that your function can take. That means these are the values that your function can take. And out of these, only B1, B2, B3 can be taken, right? F of A1 is B1 and F of A2 is B2, whatever it is. These three are attainable and B4 is not attainable. That's why B4 is not in the range. Does
Can
anyone
I
have a
also identify the range by arrows?
You wouldn't be given arrows. Like in this case, let's say you have a function. This is just to see clearly what domain, codomain, and range means. It's for the clarity. But otherwise, your functions are generally given like this, right? And then you are asked, find the domain of this. So the domain would be the values that you can put here, right? I can't put -1 here. It's not defined, right?
Yes, ma'am.
So
Okay.
-1 is not in the domain. Then coming to the range, what could be the range? Negative values. You cannot get negative values. Root x cannot be negative. This does not have a real solution, right? In fact, it does not even have an imaginary solution, I believe. So, yeah.
So, ma'am,
So,
domain is
let's
basically
just,
your output. Hello, ma'am.
yeah.
Ma'am, domain is basically your output and codomain is basically your
No,
input,
no.
ma'am.
In simple words, domain is input. Input means what you can put here, right? If this is your function, root x is your function, what are all the values that you can put here? That's your
Ma'am,
input
hello, ma'am.
thing. Yes.
Then, ma'am, what is codomain?
-1 square root over can be -1, ma'am.
What? -1?
-1 square root over.
This?
No, ma'am. -1 square root over.
-1 squared and then this is just 1.
It can't be -1.
No, it cannot be -1. So when you use this symbol, let me just clarify this thing. Let's say you have square root of 4. This is just 2. You can't say it's -2. That's why whenever you have to include the -1 as well, you write plus minus here. Is that okay? Like in your quadratic formula, you do this, right? Minus b plus minus b square. If square root meant both plus and minus, then why would you use the sign here? Right? Square
Ma'am,
root simply, yeah.
Ma'am, basically, I want to ask that domain is input. Then what is codomain and range, ma'am? Because I confuse
Range
in
is
this term.
output. Range is output. That
And
means
what is
what all
codomain?
values. And codomain
All
is
elements
what
of B.
contains
Ma'am,
your,
possible values of output.
yeah. Codomain is a set that contains range, and you are never asked to find codomain. Let's say your range is -1 to infinity, right? If this is your range, you wouldn't be asked to find codomain. Have you ever seen a question that asks codomain? Because that's not possible
No,
for
ma'am,
you to find.
never.
You can only find
Never
range.
seen.
But you
Till
can be
now,
asked, can 2 to infinity, can this be a codomain? Now, if your function's range is -1 to infinity, can this set be codomain? You can be asked this thing.
No, ma'am.
This can't be codomain because this set does not contain your range, and your codomain is supposed to contain your range. That's all
Ma'am,
we
there
know
are
about
infinite
codomain.
sets. There are
Okay, ma'am.
infinite elements in this.
What?
From -1 to infinity, that there is a value started from -1 and it is ending in infinity.
Yeah. So the thing
You can-
was, if
you
this
can-
is your range,
You can figure out the codomain because it'll always say the function is mapping
Yeah.
from R to R, R to Z, right? So essentially, whatever it is mapping to on the other side is literally the codomain. We can still find the codomain, right?
It's
ma'am?
a-
So for example, if it's R to R, I'll just say it is minus infinity to plus infinity is my codomain.
let's say if your function is okay, when you're given functions, when you're asked to find the domain, then do you think your domain is they'll give you f from R to R? If they're giving you f from R to R, that means, right? But you're asked to find domain of questions, right? That's a legit question. Domain it's called. Let's say I've been given root x. Then what happens is, if I want to, I can define this function from -1 to 2. I can define this function from 1 to 2, and then this. I can do this. Now this is definitely, now if you'll be asked what's the domain of this function, then it's
Hello,
1,
ma'am.
2. But if you're asked to
Not
find the
clear,
natural domain,
not
you can be asked
clear.
to find the natural domain, right? What? Okay, let's simplify things. You would not be asked to find codomain. That's it. Codomain is never generally
Okay,
asked in
ma'am.
questions.
Ma'am, moves ahead.
Okay. Then let's have the type of functions. You have one function,
1, 1 and on 2.
which is also called the injective function, and then onto function, which is also called the surjective function. So your one function is, let's say you have fx1 equals to fx2. That means if the function's value at 2 points is same, then your 2 points should be
Element should
same.
be same.
Right. So it basically, this is your one function, and then your onto function is, let's say if your function is from this domain to some codomain CD, then this is a surjective function if for all y belonging to codomain there exists, this is the symbol for all y. That means whenever you have a y in your codomain, you should get an x in your domain such that fx is equals to y. That means if this is your codomain, this is y1, y2, and yn, let's say, and this is x1, x2, and xm, let's say, then for this function, and let's say there's a function from here to here. So for this function to be onto, this simply means that for every y here, this is your codomain, right? For every y in your codomain, let's take yi. Every y in your codomain, you should have an x such that any x such that that x's image is y. That's given y, right? And that should be true for every y in your codomain. So that is your onto function.
Ma'am, is it
Yeah.
okay to prove the given function f of x is equals, like if we'll solve it equating it to y, so if it is equal, can we say like that?
Yeah, you can say like that. Let's say you have x plus 1. If this is your function given, if that's what you're saying, and then you're saying, let's take the function from R to R, right? And then you have to find if this is the one function or not. Sorry, onto function or not. Then what you do is, what you take an arbitrary element from from this real number set. So arbitrary R means random R. We don't know what this R is, but we know that it belongs to real numbers. And then you test if you can find an x such that x plus 1 is R. So in this way, in this one, it's very simple. You can find x, your x will be R minus 1, and it's in this R, right? Sometimes what happens is, let's say, here you have
Ma'am,
R minus 1.
My doubt is about should we check that each about the codomain technique, or can we also do like this? Is it compulsory to check the codomain thing?
Yeah, you have to check it for every element in, you see, possibly you cannot check because if your codomain is real numbers, can you check for it? There are infinitely many numbers here. You can't check for every number, right? That's why we're checking for a random R. Do you get it? Like, let's take this example. Let's say your function is from the set R, real numbers except 1. You know what this symbol means, right? R minus 1 means the set of real numbers minus the number 1, right? and from this is your codomain. So what I need to know is if this is your given function x plus 1, then I have to make sure that for every r, for all r belonging to real numbers, there is one x belonging to, what do I need for every r belonging to r? If your function is this, let's say, this is your function, then I want for all r belonging to this capital R, this codomain, there exists at least one. That means that there should at least be one element here that is mapped to this small r, right? That means there exists at least, let's call it x. There exists x belonging to domain r minus 1, which is your domain, such that f of x is equals to r. So for example, your function is x plus 1, right? So what do I want? For every r belonging to this codomain, I want an x from the domain such that the image of this x should be r. This x could be anything, but it should be in my domain. That's the bound on x, that it should be in my codomain. Let's for example take x plus 1, that I want fx to be equal to r, where r is arbitrary, right? Now let's take x plus 1 is equals to r. What should I take x such that x plus 1 is r?
R minus 1.
Right. So my x should be equal to r minus 1. But my problem now is if I'll take r is equals to 2. Because I have to make sure that for every r belonging to this codomain, I should get an element in the domain whose image is that element, right? So if I'll take r is equals to 2, belongs to real numbers, right? So 2 belongs to codomain. But do I have an element in my domain such that the image of that element is 2? I want x plus 1 to be equal to 2.
Yeah, x is 1, ma'am.
So x will be 1. But my domain is r and 1 is excluded from that set. That means this function is not 1, 1. Sorry, not on 2. Is that okay?
Yes, ma'am.
Okay. So this is, does anyone have a doubt in the example that we
Can I
discussed?
ask you something in dot?
Yes.
1 1 on 2, can you simple term?
You want 1, 1 on 2 in simple terms, is it?
Yeah, ma'am.
Okay. So, just 1 second.
Because so many questions are lengthy, so I don't identify 1 1 and on 2, so more difficult.
We were here. Let's come to the 1, 1 on 2 part. Your 1, 1 function says
Yeah.
that if you have two elements, let's say you have x square function, the simplest example of a function which is not 1, 1, let's take x plus 1 function and x square function. Let's take two functions, right? Fx equals to this and gx equals to this. Now, if these
Yeah.
are two functions, let's first discuss fx. Then for 1, 1, what you have is, you say that if my fx1 is equals to fx2, let's take this. It says if this is true, only check if this is true, right? If this is true, then x1 should be equal to x2. This should be true as well, right? So whenever images of two elements are same, the two elements should be same. So your images are, if images of two, let's say the image of x1 and x2 are same, let's say, that means x1 plus 1 is equals to x2 plus 1, right? Who's on unmute? There's a lot of background noise from there. Okay. So if you have x1 plus 1 and x2, if two elements at x1 and x2, you have same images, that means this is true, right? Now 1 can be cancelled from both sides, right? This implies x1 is equals to x2. This means whenever the image of under this function, whenever the image of two elements and x1 and x2 are arbitrary, random numbers from the domain, right? So whenever the image of two random numbers is equal under this function, the random numbers are also equal. That's why this is a 1-1 function, right? Yeah.
X1 and X2, these are arbitrary.
Yeah, arbitrary. They're arbitrary in the sense arbitrary means
Any number,
yeah.
any number are put in this X1 and X2.
Yeah,
These
arbitrary.
are codomain.
Yes, arbitrary from your domain. Make sure your x1 is from the domain. That's it. Okay,
Okay, ma'am.
that's it. Now let's say you have a function x square. Now your function is x square. So I know that x1 square, let's say x1 square is equals to x2 square. This is gx1 equals to gx2. Now if this is true, then can I say that x1 and x2 are also same? Can
No,
I
ma'am.
have two numbers different whose square are equal? So we have two numbers different, right? -1 and 1 are those two numbers. And there are a lot of other pairs too. But for now, let's consider this -1 and 1 pair. -1, square of -1 is also 1. Square of 1 is also 1. That means
This is
you can
not
have
1,
two
1.
numbers. That's why it's not 1, 1, right? But this is
It
when
is
your
many
domain
terms.
is when your domain is R. Let's say my domain is R. Then I say that Gx is not 1, 1, right?
Yeah.
Just 1 second. This implies Gx is not 1, 1. But if I'll take Gx is equals to x square, and if I'll take the domain to be, because one is natural domain, if you're not given any domain that you consider that, then you consider the natural domain, and the natural domain for x square is real numbers. But if you're given the domain, let's say my domain is given to be from 1 to 2, if this is my domain, or from 1 to infinity, let's say. Or let's say from 0 to infinity. If this is my domain, then is this function 1, 1 now?
Yes, the function is 1, 1.
Now this
Yes,
becomes
ma'am.
1, 1, right? Because what we need to make sure is if gx1 is equals to gx2 for x1, x2 belonging to the domain. So they're saying if the value at 2 points is same, and for the value to be calculated at those 2 points have to be in the domain, right? Now, if you say -1 and 1 have different squares, that's fine, but -1 is not in our domain, right? That's why this is a 1, 1 function. Is that okay? And a simpler way
Okay,
to
ma'am.
check if you can deal with graphs, that's very useful. We already know that if you have x square, its graph looks like this. So we only have to make sure that if I make any horizontal line here, horizontal as in a horizontal, if I'll draw a horizontal line parallel to x-axis, then it should cut your graph only at one point. Any horizontal line parallel to, not just, now this one is obeying the rule, but these ones are not obeying that rule, right? That any horizontal line parallel to x-axis, so any line parallel to x-axis should cut your graph only at one point. That's when I say that it's a 1, 1 function. This is not 1, 1 because this is x square defined on with domain minus infinity to infinity, right? But if I'll do this thing, this is again x square function defined on domain
0 to
0 to
infinity.
infinity, right? Now, if I'll draw horizontal lines, any horizontal line, no matter which horizontal line, is going to cut my graph only at one point. That's why it's a 1, 1 function. So that's the graphical test for you to check if it's a 1, 1 function or not.
Ma'am, based on this, is it safe to say if a function is strictly increasing or decreasing, it's always 1, 1?
If it's, yes, if it's strictly decreasing or strictly increasing, it is 1, 1. Okay. So can we move
Can
to the
you
next week?
explain strictly increasing and strictly
Yes, ma'am.
decreasing function?
Which one? Which one do you have a doubt in? Someone had a doubt somewhere.
the function is strictly increasing or strictly decreasing.
Okay, strictly decreasing, strictly increasing, and I don't think that's in your syllabus for 4 weeks, but let's discuss it here. Strictly increasing means,
But in mock test, there is a question relating to this.
okay, so if your function is strictly increasing, that means if my f strictly increasing means if x1 is less than x2, where x1 and x2 are in the domain. I'm denoting the domain with a D. This should imply that fx1 is strictly less than fx2. You do know what strictly less means, right? This means they cannot be equal. fx1 has to be less than fx2. They can't be equal. This means fx2 is greater than fx1. This means fx2 is strictly greater than fx1. So that's what's given to you. So what's given to you is either you write it or not. It's the same thing. This means x2 is strictly greater than x1, and this means fx2 is strictly greater than fx1. It simply means this is greater than this. They cannot be equal. That's the idea of strictly. So what does it mean is, let's say you have 2 points here. This is x1 and this is x2, right? If x2 is strictly greater than x1, then this is what they look like, right? You take the domain on this side and code and your range on this side, right? Range or codomain, whatever. Right? So you have x1, x2 strictly greater than x1, then your fx, let's say if your fx1 is here. fx1 here means this height is fx1, right? This height is called fx1. So if this height is this much, then at x2 your height should be greater than this height, right? That means your x2 should be above this. Are you getting this? Above this line. Because this is the height of fx1. So I want the height fx2 to be greater than this. Is that okay? So I would want, if I say this is fx2, then it's fine. It's satisfying this property that fx1 is strictly less than fx2. But if it's here, let's say it's on the equal height. If they're on the equal height, then this is not strictly increasing. So let's have a look at this function. Let's say I have a function this, where this is a straight line and then it goes up. Let's take this straight line. Let's take this instead. So is this a strictly increasing function? This is a straight line, even if it doesn't look like one, but it's a straight line parallel to x-axis. So is this a strictly increasing function?
No.
It's not a strictly increasing function because you have 2 points x1 and x2, and the height at both these points is x1 is less than x2, but fx1 is equal to fx2. Right? This should not happen. Your fx2 should have been strictly greater than fx1. That's the problem. Now coming to this one. What about this one? This is a strictly increasing one, right?
Yes.
Yes,
This
ma'am.
is strictly increasing
Because
function.
it is going upward. It is going upward.
Yeah. It's going upward and it's not becoming constant anywhere, not even for a second, right?
So, ma'am, if ma'am, hello, ma'am.
Yes.
It is going in positive direction. Okay, in upward.
Yes.
Okay. If, for example, if you tend the line to the second quadrant, means, ma'am, in negative direction in upward, so it can also be in positive.
Yeah. What are you saying? This thing?
Yes, ma'am. Yes, ma'am.
This is decrease. You have to start from here. You only have to start from this side. And if you look from left to right, you will see it's decreasing, right? This is a decreasing function.
So, ma'am, we have to only start from right side, no, ma'am, not left side.
From left, it goes from left to right. So
Okay,
this
ma'am,
is your
from
left
left to
side, right? You have to go from here to here. And then you have to see if it's decreasing or it's increasing or what's happening, right?
Okay, ma'am. So we can't go to the right to left, only from
No.
left to right.
No. Yeah, you only have to go from left to right.
Okay, ma'am.
So this one is a decreasing function, or you can say it's a strictly decreasing function. Okay, then is this fine? I think we're done with the, and then you have bijective one things left. One is a bijective function, which is both 1, 1 and onto. Bijective is 1, 1 plus onto. That's it. So, and I think this is it. We're done with the first week. Now we'll come to the
Oh.
second one. Yeah.
Straight line.
So your second week is on coordinate system, right? Coordinate geometry. So
Yes, ma'am.
first is I'll quickly go through the formulas because you only have to remember the formulas. So first is let's say you have x1 and y1 as 1 point and x2 as and y2 as the second point. Then the distance between these 2 points is x1 minus x2 whole squared plus y1 minus y2 whole squared and then square root. This is the distance between 2 points. Then you have section formula, which is, let's say you have these 2 points, x1, y1, and the other point is x2, y2. And you have a line passing through these 2 points. By the way, there's a unique line passing through 2 points. So there can only be one line passing through these 2 points. So let's say you have to find the point such that this point divides your this line into m into n ratio. So you want to find the point, let's call it xy point, the point xy such that your xy points, this is m part of this whole thing. So this would mean that if this is m plus n, if your entire line is m plus n parts, then m parts of it is from x1, y1 to xy, and n parts of it lies on the side from xy to x2, y2. So this is n parts, and this is m parts, and total is n plus n parts. That's it. That's what you have to find. What? So the formula is for you to find this point. The formula is mx2 plus, so this multiplied with this mx2, then n x1 divided by m plus n. This will give you the x coordinate. This is your x, and your y coordinate. The y coordinate of this will be my2 plus ny1 divided by m plus n. This will be your y coordinate for this point. And then you have, or alternatively, you could be given all 3 points, and you could be asked to find the ratio in which it cuts the line. Questions could be framed in different manners. So in that case, you have been given all the 3 points. You have to find the value of m and n. So it's better, instead of taking m and n, m ratio n, let's say you have been given, we don't even know if these lie on the straight line or not, but we're taking it just for the sake of this example. Let's say this is 3 by 2 and 4. We don't, again, I am telling you that I don't know if these 3 points lie on the same line or not, but we're just doing it for the sake of this example, that if you have to find the ratio in which this point divides this line segment, then instead of taking m ratio n, you can take k ratio 1. Because in m ratio n, you have 2 variables to find, and in k ratio 1, you only have 1 variable, so things become simple. So let's say you get k is equals to 2 by 3. That means your ratio is 2 by 3 is to 1, or you can say 2 is to 3. Coming to the next thing, we have area of triangle. So your area of triangle consisting of points, let's say there are 3 points, x1, y1, x2, y2, and x3, y3. Then the area is given by half of x1, y2 minus y3, then x2, y3 minus y1, and then x3, y1 minus y2. That's the formula for the area of triangle that has these three as vertices, where the vertices are these. If these three are the vertices, then this is the area of your triangle. And then we have a slope of a line. So for you to find a line, a unique line, you'll at least need 2 points or 1 point or slope, right? So slope of a line is basically, it's the tan of, okay, because we're not doing the entire summary, so I'll just write the formulas for each of these. So if you have to find the slope of your line, then one way to do it is, because we're discussing slope of straight lines. So for slope of straight line, you can simply take the 2 points on that line. Let's say you have 2 points, x1, y1, and x2, y2 lying on that line, on L, where L is a line, a straight line. Then slope of L is y2 minus y1 by x2 minus x1, or you can reverse the orders too, that's fine too. The signs will get adjusted accordingly. So this is the slope for your straight line. Then we have the general form of, let's just write all the forms of line. First is your general form, ax plus by plus c equals to 0. This is the general form. For example, let's take this 3x plus 2y plus 9 equals to 0. This is the general form. Then you have this 1 point and slope form, which is y minus y1, where you require 1 point, and then mx minus x1. So this is point slope, where your point is x1, y1, and your slope is m. So you're using a slope here and you're using a point here to find the equation in this form. Then next up we have a slope intercept form. So your slope intercept form is this: y is equals to mx plus c, where this is your slope of line and this is the intercept. By intercept, we mean y-intercept. So this is slope intercept. Slope intercept form, M and C.
Excuse me, ma'am.
Yes.
How to calculate x-intercept?
For you to calculate, let's say you have a function fx. This is valid for every function, by the way. Let's say you have a function y is equals to fx, or let's say you have x minus 1 plus x plus 1 whole squared, and you have to find, this is your function, and you have to find you can write fx as y, right? So for you to find x-intercept, put y equals to 0 and solve for x. And for you to find y-intercept, put x equals to 0 and find the value of y. Is that okay? So let's say you have, if I were to write it in general, this is how I'd put it. If y is given to be fx for any function, then for x-intercept, put y equals to 0 and solve for x. That x would be your x-intercept, and for y-intercept, put x equals to 0 and solve for y. Right? For example, let's take this x plus 1 whole square is equals to y. Now, if you have to find the y-intercept, put x equals to 0, you'll have 0 plus 1 whole square. So this will be y equals to 1. So your y-intercept for this is 1. Or in points, you have 0, 1, right? So your y-intercept is 1. And what's your x-intercept? Put y equals to 0. You'll have x plus 1 whole square equals to 0. And this, when you will solve, you will get x is equals to minus 1, right? So this is your x-intercept. This is your y-intercept. Is this
Okay,
okay?
ma'am, got it.
Okay. Then the intercept, the last form, the intercept form. So your intercept form is basically x by a plus y by b is equals to 1. This is intercept form. Where a
And
is the, yes.
there is a 2-point form also.
Okay, let's do that too. The 2-point form is this. Y is equals to, how do you find the slope? What's the formula for slope?
y2 minus y1 over x2 minus xy.
Right. So this will be y2 minus y1 by x2 minus x1. This entire thing. And then here you can take x minus x1. And here you can take y minus y1. This is your 2-point form.
Firstly, we can find the slope from 2 points and then simply use the slope intercept form.
Yeah, that's actually better if you
Okay,
can do
ma'am.
that. 2-point form is just for you to know that this slope is calculated by 2 points only, right? So if what happens is sometimes you're not given the slope of the function, you're given 2 points. This is when you can use the 2-point form. When you're given the slope and intercept, even when you're given 2 points, you can still use this form, right? You can still use slope intercept form. That's still valid. Okay. And the last one is intercept form. Which is, I think this, right? X by a plus y by b is equals to 1. Wait, if I put y equals to 0, I'll get x is equals to a, right? Where a is your x-intercept and b is your y-intercept. This is your intercept form. I think we're done with all the forms. We're done with how to find x-intercept and y-intercept for a function in general. And then we have angle between two lines. So let's say you have two lines. This is L1 and this is L2. And let's say this is the angle theta. Then this angle is tan of this angle is equals to M2 minus M1, where M2 is the slope of this. M2, slope of L1, L2, slope of L2 is M2, and slope of L1 is M1. So this is M2 minus M1 divided by 1 plus M1 M2.
M1 into M2.
So this is how you can find the theta. You can take the tan inverse of this. If you have to find the theta, you can take tan
Ma'am,
inverse
may you
on this
please?
side.
Hello, ma'am. Hello, ma'am.
Yes.
May you please explain this formula again, because I get confused in this formula.
Okay, this
Oh,
says if you have a line L1 and the slope of the line L1 is M1, let's say, and then you have a line L2 whose slope is, let's say, M2, then the angle between L1 and L2 is given by this theta, where tan of theta is equals to mod of this is a simple formula. That's it. We've not discussed anything.
Ma'am, I have a question.
okay, ma'am.
Yeah.
Can we find the angle of upper part?
What?
We just found the angle of the side.
I can't. I cannot
Can-
hear you very clearly.
Can we find the angle of the upper part?
The upper, that's why we have a mod here, right? So the mod is, let's say you have, this is tan theta, and let's say this entire thing you get as 1. Then it is, and let's say these two are your lines. This is your system. Let's take another diagram where you have, let's say, this one line, which is making an angle, and then this is another line, let's say, right? And then if your tan theta is 1, this is 1 theta, the other theta is this, right? So you'll have tan inverse of
Basically,
the other
because
one
you
is
have
why
a
you
no.
have,
Yeah. So because you have a mod,
here,
right?
so
It will be
both are
plus or minus
included.
1.
Yeah. So this is tan theta, and when you solve this entire thing, let's say you get 1. So if this entire thing solves, just 1 second. This is, you'll get plus minus 1 here. Let this slope is, let's say, we'll need to take an example for this, and I cannot think of an example right now. If this solves to can someone find an example from the questions on the portal?
What example do you require, ma'am?
For us to illustrate that these two angles are included here. That's why we have a mod sign here. The thing is, this says theta is equals to tan inverse of this thing. So you will have something positive here, right? And then even if you have minus 1 value here, the mod value will always be 1. So you will have tan inverse of 1, and this theta will be
45. Yeah,
45, right?
It's usually the
So-
acute and obtuse angle, right, ma'am? The one determines the acute and other one will be the obtuse angle between these two.
I think this one gives you the acute one, right? But in this case, the 45 one, both are the same, 45, 45, right? So just 1 second. If you have these two lines, if this is, okay, if this is 45 degrees, the other one will be 135, right? Right, the other one will be 135. But this one's, yeah, this one's for acute one, I think.
Yes. For
Tan
the
of
And
180
the-
minus 45. So that will be minus tan 35, which is what you are getting. That's correct.
Yeah. So the other one for 135, it's like, from what I remember, it's pi minus something, and I don't remember that formula
pi minus
right now.
theta.
Yeah, we have one of that form too.
Tan of 180
Pi
minus
minus-
theta is minus tan theta. That's what it is.
Yeah. Is it clear?
Yes, ma'am. Move further.
Yes, ma'am.
In the actual book, they are also given the point which diverts the line externally, but I have not seen any assignment on that one. So is that something that we need to study?
I don't think so.
Okay.
If you don't
Oh,
have
I
to,
was
but if you
saying the
want me
mx2
to,
minus mx1. That's formula.
That's
if
right.
you want me to write that down too, I can write that formula down too, but I don't think that's required.
No, ma'am. Prof thought that.
Okay, where did we do that formula? Here, right? Can we come to that one later, because we have more important things to do that you'll
Sure.
see in
Yes,
exam.
ma'am.
That's why.
Yes, ma'am.
So, okay, let's do that first. And then you have lines and perpendicular lines and parallel lines. So for parallel lines, your test is that your slopes should be equal. So if you have two lines, L1 and L2, then the slope of these two lines, let's say the slope of this is M1, the slope of this is M2, then this should be equal. The slopes should be equal for parallel lines, and for perpendicular lines, your slopes should be the product of your slopes, L1 and L2. If the slopes of L1 and L2, M1 and M2, the product of these two slopes should be -1. Then we say that two lines are perpendicular to each other, and in this case, we say they're parallel to each other. So, and then we have distance formula. The distance formula between a point, let's call the point x1, y1, and a line. Let's say the line is ax plus. For you to use the distance formula, it's important for you to have the equation of line in general form. This is the general form of your line. So bring the equation of your line into general form and then use this formula. So it says the distance between this point and this line is going to be, substitute x1, y1 in this equation. So you will have, not in this equation, just on the left-hand side of this equation. So it's ax1 plus by1 plus constant and the mod of this divided by square root of a square plus b square. A, b are coefficients of x and y in this line. So that's the distance between the point and the line. And then next up, you have the distance between two lines. And when we say two lines, we mean two parallel lines. So the distance between two parallel lines is, and the special thing about parallel lines is the distance remains same, right? So if you have this point, the distance between this point and the point that's here, this is going to be the same as this distance here and here, provided that this line that you've drawn is perpendicular to both these lines. Okay. So let's say you have been given two parallel lines. One is ax plus by plus c. Again, you will need this equation of these lines in general form, ax plus by plus c, and this will be ax plus by
plus c1.
Right. So they'll only vary in the constant term. You can check this too, because they're supposed to have same slopes. That's why they're only going to vary in this constant term. The coefficients of x and y are going to remain same. So let's call this C1. Let's call this C2. That's better. So the distance between these two lines will be
mod C1, C2.
Mod C1 minus C2.
mod C1 minus C2
Root
divided
over
by
Under
a
root
square
a
plus
square plus b square.
a square plus b square.
right. So this is it. That's what you have to find, that when you have to find the distance between two parallel lines and the distance between a line and a point. That's it. And then we have other 2 weeks left as well, right? And we have not done a single question. We'll have to schedule one more session tomorrow. Do you guys have sessions tomorrow? Do we have any session from 8 to 10 tomorrow?
8 to 10. Yeah.
No, ma'am.
No, ma'am. I think no. I think no.
Okay, so if there is no session tomorrow, we'll schedule one more session for revision tomorrow, because
Okay, ma'am.
we need one more session. Okay, then week 3 quick summary is this.
Ma'am, 4
Yeah.
to 6.
Ma'am, so can you take that down now?
No, we're not done with I was planning to discuss week 3 and week 4 quick summary, and then maybe some questions. And if we're not doing the week 3, week 4 summary, then let's do questions from week 1 and week 2, shall we?
Yes,
Ma'am, hello,
ma'am.
ma'am.
Yes,
Yeah.
it is.
Yes, ma'am.
Question will be correct.
Ma'am, in
Okay.
straight
Next
line,
year,
there is one more formula like m equals to minus a divided by b. Ma'am, what is that? Does that use for?
Which one?
M is equals to minus a upon b.
Minus a upon, so you must be talking about this then. Ax
Yes, ma'am, the
plus
general
by
form.
plus c is equals to 0. And then this is, okay, what you have to do is, for you to find slope, first you have to isolate y. So if isolate y as in, y should be here and all the other things should be on the other side. So you have to write it in this form first, right? So it will be y
It is like
is
slope
equals to,
intercept form.
right, minus ax plus minus c.
Minus
Minus
b.
ax minus c, and then you will divide by b, right? So this gives you, now if you look at this clearly, this is your slope intercept form, which is y is equals to mx plus c. So if you compare the things from here, your m is equals to minus a by b. That means your slope is minus a by b. And your intercept, y intercept is minus c by b. Is that
Yes.
okay?
Okay, ma'am, can we use this formula instead of x2 minus x1 upon y2 minus y1 that we use for the general slope?
Okay, you can only use that x2 minus x1 and all that formula when you've been given 2 points. And you can only use this one when you've been given the equation of the line. Now, let's say if you're only given 2 points, let's say you've been given line passing through 2, 1 and 1, 10, then you will have to use that formula for slope, right?
Okay.
because the equation of line is not given.
Ma'am, can you
Okay.
give an example
Ma'am,
of
move
this
to question,
question?
please.
If someone had a doubt somewhere, yeah.
Yes, ma'am. Can you give a little example of this one?
Of this one,
Yes, ma'am.
okay, let's say when you have, if you have been given a line 2x plus 4y plus 7 equals to 0. If this is your given line and you have to find the slope of this, then all you have to do is you have to find minus a by b, right? Or you can just see you have to take y on this side and x on this side. So if you will take x to the other side, this will be 2x minus 2x by 4, right? Forget about the intercept for now, but this is what you're going to get, plus some constant, right? So your slope is going to be minus half. This is when the equation of the line is given to you. But if you have been given 2 points, let's say 1, 2 and 2, 4, then for you to use this approach, first you'll have to find the equation of line. And for that too, you need the slope, right?
Okay.
Your equation of line is either you will use this form y minus y naught is equals to y1 minus y naught by x1 minus x naught. And if you only have to find slope, why are you using the equation? That's not asked, right? Don't find it unnecessarily. If you're only asked slope, just find the slope directly using the y2 minus y1 formula.
Thank you.
Okay.
Ma'am, I think
intercept is a
one
minus b
concept
by
is pending.
2 है ना ma'am?
Ma'am,
Which one?
one question, please.
Yeah.
Equation of parallel and perpendicular lines in general form.
Okay. I think if let's say you have parallel, we have already discussed the parallel lines one. When we were discussing the distance between two parallel lines, we discussed this, right? This is the
Yes,
general form.
ma'am.
Yes, ma'am.
So parallel lines is where your slopes have to be equal. Let's say first line you took is ax plus by plus c. And then you have to find the equation of a line that's parallel to this line. So what should it look like? We only know that the only condition is the slope of the other line should be equal to the slope of this line. So the slope of this line is minus a by b, as we have seen. So the slope of the other line should be y is equals to minus a by bx, and then some constant, we don't know what that constant is, right? So it should be by plus ax minus some constant. So it's the same as ax plus by plus some constant. So in simple words, for the line to be parallel to this line, parallel lines should look like this. So all parallel lines, let's say this is L1. All lines parallel to L1 have equation of this form. Ax plus by plus some constant equals to 0. Is that okay? And then the other one is for the perpendicular ones. So let's say you have L1 given, and then you have to find L1 is, let's say, ax plus by plus c is equals to 0. You have to find equation of all lines or general equation of lines perpendicular to L1. So it should be, this slope is again minus a by b. And what should be the slope of the line perpendicular to this one? It should be b by a, right? If the slope of L1 is minus a by b, then the slope of the line that is perpendicular to L1 should be b by a, because I want the product to be minus 1, right? M1 is this. This implies slope of line perpendicular to L1 should be b by a. That means this should be of the form y is equals to, so your general equation is y is equals to, this is how a line looks like in slope intercept form, right? And I know that the slope of this line should be b by a. We have just seen that the slope should be b by a. That means I should take y is equals to b by a, x plus some constant. So this will be ay minus bx plus some constant is equals to 0, or you can rewrite this as, I'll rewrite this as minus bx plus ay plus the constant equals to 0, where k is a constant, any random constant, right? So this is the general equation of lines parallel to this line. Is this okay?
Then move to question.
Okay. So this is the first question. This question asks you to find the maximum and minimum of the following functions. So the first function is, so if you have noticed, this function can only have, because you have this, so this is an increasing, this is an increasing function. I hope you all can see that this is an increasing function because 9 to the power x is simply an increasing function. That's why this entire thing is an increasing function. And if this is an increasing function, that means if you have an increasing function, can an increasing function have a maximum? That means this only has a minimum. That's what you've been asked to find. And this only has a maximum. Because this is a decreasing function. This is an increasing function. Increasing functions only have minimum. Decreasing functions only have maximum. First thing. But you don't need to know all of this to solve this question. Let's start with the question, the solution. So first is you have to find the minimum of fx, which is 9 mod x plus 1 minus 8. So for you to find the minimum of this, you have to find the minimum of this thing, because this is basically just a constant, and constant, it's like this thing. If you have fx, if you have to find the minimum of fx plus 1, how do you find the minimum of fx plus 1? You find the minimum of fx and then you add 1 to it, right? So that will be minimum of fx plus 1. So similarly, if you have to find the minimum of this entire function, what you have to do is you just have to find the minimum of 9 to the power mod x plus 1. And let's say minimum of this is small m. Then you just have to subtract 8 from this small m. And this will
The
give you
minimum
the
will
minimum
be
of
1
this.
for the
Okay.
first one.
Let's see if it, I just want you people to know what we are using here, what all facts are we using here. So this is, what's the minimum of this thing? 9 mod x plus 1. Now this is an increasing function if you'll test, right? So its minimum will be, either you can try to find these values. If you'll have 1 here in place of x, if you'll have 1, this will be 9 to the power 2. If you'll have 2, this will be 9 to the power 3, 9 to the power 4. This means it's constantly increasing. So for you to find the
X would be
minimum,
0,
you need, right? For you to find the minimum of this, you will have to have x equals to 0. So this will be 0 plus 1. And this will give you 9 to the power 1. Every other value would be 9 to the power 2 or 9 to the power 2.5 or 9 to the power 1.6, because this is 9, 1 plus mod x. So the power is definitely greater than 1, right? So that means the minimum of this will be attained at, yes.
Ma'am, how you find the gx? Please explain me again because.
Gx?
Yes, ma'am.
We're not finding gx. Gx is given to
9x. 9x, not gx.
This is 9. Okay. This is 9.
9x? How it is 9x, ma'am? Oh, okay. Sorry, ma'am. Ma'am, I am.
This is just 9. Yeah.
Ma'am, please, you are the question. So to see the whole question. Yes. Ma'am, g of x is given in 11 minus x upon 8, x plus 8 upon x square. How can we solve that gx, ma'am? Because we have
Okay, we'll come to gx later. Let's first do it for fx, right? Is the fx part clear to you?
Yes, ma'am. 9x plus 1 is equal to n.
For this, you need to know that, okay, your 9 mod x plus 1 minus 8 will be minimum when 9 mod x plus 1 is minimum. And this will be minimum when mod x plus 1 is minimum. And this will be minimum when mod x is minimum. That is how you have to reduce things. Why? There is a reason for it. Because this is an increasing function. Your 9 to the, this is this comes under composition and you have not, let's not go there. For now, you only need to know that the minimum of this will be attained when this has the minimum value, and consequently when your x has the minimum value, when mod x has the minimum value. So what's the minimum value of mod x?
0.
0. That's why you will have to take, for you to find the minimum value of this, you will have to take x is equals to 0.
Ma'am, how will you
Minimum
find
value of
the
fx is 1.
Ma'am,
fx is equal to 1. Is it right?
अयो मैम मैं ये
Yeah.
कहना चाह रहा हूँ, आप मिनिमम ऑफ 9x plus 1 equal to n रख लेंगे। अयो
Yes.
तो मैम आपने 9x plus 1 minus 8 किया,
Hmm.
तो क्या यही हमारी मिनिमम वैल्यू होगी? फिर क्या 9x minus 1 minus 8 मेरी मैक्स, अरे क्या बोल रहा हूँ मैं, 9x plus 1 plus 8 मेरी मैक्सिमम वैल्यू होगी ना मैम?
इसकी मैक्सिमम वैल्यू तो आप निकाल ही नहीं सकते, because this is an increasing function, right? This function looks like this. This is just a rough example. It doesn't look like this. This is just for you to know that this is an increasing function, so it's something like this. That means it does not have a maximum value. It keeps increasing, right? But it has a minimum value here. This is its minimum value, right? This is its minimum value. This height is its minimum value. And maximum height, we don't know, because it keeps increasing. So we don't know what's the maximum height. So you can't find the maximum of this function. You can find the minimum only. And the minimum is, this function is minimum when you're 9, when this function is minimum. This symbol is for if and only if. And this is minimum if and only if mod x plus 1 is minimum. And this is minimum if and only if mod x is minimum. That's the idea.
एक बार फिर से आप स्लाइड ओवर करिए मैम।
What?
मैम स्लाइड ओवर करिए मैम, एक बार क्वेश्चन हुआ ना या फिर देखना है। यस ओके मैम, -8 जो है मतलब वो नेगेटिव है, तो इसलिए वो मिनिमम वैल्यू हो गई। ओके मतलब वो नेगेटिव है इसलिए नीचे जा रहा है।
No. This thing has a positive sign here, right? If you had minus here instead, if instead you have -9 mod x plus 1, then this is a decreasing function now. This is a decreasing function. And because it's a decreasing function, it cannot have a minimum value. Its value keeps decreasing. Do you get it?
The coefficient determines
The sign is, this sign is mattering here, this positive sign. Positive 9 is what matters here.
And the maximum of gx will be 11.
Yeah,
Okay.
I think we can move on to gx.
And then coming up to the next one. So this is minimum of 9 mod x plus 1 minus 1. Or this one is just minimum of this function is 1. And minimum of this 9 mod x plus 1 minus 1 is 0. Is this question clear?
Because -8.
-8.
Yeah. This, okay, we have a 1 here.
No. It's 9 minus 8, 1.
I thought this is just 9 to the power mod
This
x.
is an exact answer value, ma'am.
So if you have 1 here, this will be 9 to the power 0 plus 1. So this is 9. And this will be -1. So this is 8. Right. So this is going to be 8. 1 second. We
And
have
the
a
nine
minus 1
minus
here.
8.
Yeah,
Okay,
9 minus
okay.
8.
We have 8 here. Okay. This is 8.
The minimum value will be 1.
So the minimum value here is 1, right?
And the maximum of gx will be 11.
And then we have
मैम आप एक बार
gx.
स्लाइड को नीचे करिए मैम। आपने मैम एक मिनट मैम, स्लाइड जहाँ पे सोल्यूशन है वहाँ पे मैं कह रहा हूँ, जहाँ पे सोल्यूशन है वहाँ पे, हाँ पूरा सोल्यूशन। मैम आपने 9x प्लस 1 9 mod x किया तो ठीक है, 9 mod x प्लस 1 आपने या फिर आपने 9 mod x को 9 ब्रैकेट x में लिखा, 9 मीन में 9 ब्रैकेट x प्लस 1, तो मैम 9 माइनस मतलब मॉड ऑफ x प्लस 1 मतलब 9 की पावर 1 0 हुई तो नहीं 9 की पावर 1 होगी तो मैम 9 माइनस 1 ऐसे हुआ है क्या?
I don't get your question. मेरे क्वेश्चन ही नहीं समझ में आया आपका क्या पूछ रहे हो. Just 1 second.
मैम मैं
Ma'am,
पावर में
change the
कंफ्यूज हो रहा हूँ.
question.
Ma'am, is the class time extended because it's already
Yeah.
10?
We'll go a little. Is that okay to you people? Because
Yeah,
Yes,
even if we are taking
no
week
problem.
3, week 4 tomorrow, we'll have to cover something today, right? And yeah, what
Ma'am,
was the doubt?
Can we close the?
This question is very similar to the previous one. In this one, you have to find the maximum. Maximum is 11 minus whatever is there. It's in mod. So if you have to find the maximum of this, the maximum of this is attained when
the
this
mod function
is,
will be minimum.
yeah, or you can say when this is the mod function, when minus of this mod is maximum, and this happens if and only if when the positive of this mod is minimum. And this happens if and only if we're done here, right? So we have x plus 8 by, what is it? X square. So you have
Ma'am,
to
the x
find,
equal to minus 8, it will
so you
be
have to
0
find,
then.
yeah, where this thing is minimum, and the minimum value, because this is under mod, that means the minimum value, any modulus function, if you have mod f, the minimum value it can take is, it is either 0 or greater than 0. It cannot be less than 0, right? So the minimum value this can take is when your x plus minimum of this is attained. So minimum of this, minimum of mod f is attained when your fx is 0. This is minimum where your fx is 0. So in a similar way, this is minimum when your x plus 8 by x square is 0. And where is this 0? When your x is equals to minus 8. So this is it. That means your minimum value is attained at x is equals to minus 8. And what is your minimum value? Put minus 8 here. So you'll have minus 8 plus 8, 0. So the maximum value will be 11.
11.
That's it. And then I think you have to find the product. So it's 11. Moving on to the next question.
Sorry, ma'am. I recall this problem. Actually, this problem had an incorrect answer in the assignment. It was not 9 to the power mod x plus 1. It was actually 9 into mod x plus 1. And unfortunately, I think the answer in the assignment was
It is
wrong.
printing problem.
9 to the power. What was it?
Sorry. Okay. I don't know if I can. It was actually 9
9
into mod x plus 1. 9 into mod x plus 1.
Okay,
That's
so
not
it was
9
this.
to the power. Yeah. And the answer because in this case, now what is going to happen is, yeah, it will be a little
This
different.
still, you have to find what is that
Sorry,
you have to
Then
find.
it
You have
will
to
be
find the
minus
minimum value.
7.
No, 9 into mod x minus 8. That's the actual sum. 9 into mod
9
x
in-
minus 8. Minus 8. So the
Okay, so if
minimum
you have
value
to
is going
find
to be
the
minus 8.
minimum of this,
This will be minus
yeah,
8.
because the minimum value for this is 0. So the minimum value for this entire expression will be minus 8, right?
Yeah.
That's
So
okay. That
yeah, I
must be a
recall.
printing
Yeah,
mistake.
because
Then.
I recall putting it as minus 88 as answer, but when I submitted, it said minus 77 is answer. So I actually posted this, but anyway, I don't think anyone
Yes,
has seen
yes, I
this.
have faced also this problem. Yes.
That's okay. The grade assignment do not have
Sometimes the
impact on your final
assignment,
results.
Okay.
assignment and some graded assignment also some incorrect.
We're trying to rectify it. I hope you won't see it in further weeks.
Ma'am, so
Okay.
ma'am, whenever the mod is positive, we always tend to find the minimum of it. And when the mod is healed with the negative sign, we have to find the maximum value, right?
Okay, when you have, let's say you have minus mod of x plus 2 and you have to find the minimum, you have, okay. You have, let's say you have to find the minimum value of this. The minimum value of this is, or let's say you have an 8 here too.
Zero.
The minimum,
Why put
Minimal
minus
would be 8.
8.
in this
Why
case,
put
it's
minus 8?
because someone was saying that if it's minus mod or if it's plus mod. So I was just trying to clear that doubt. That's it. That's why we have taken a minus mod here.
Yes, ma'am.
So the maximum value, the minimum this function can take is 8, right? Because constants do not make any difference to your maximum minimum. You can instantly remove them from your equation and then just focus on this part. So this is minimum. If you have to find the minimum of this, because it's a mod function, and
It
mod
is
functions
0,
are
ma'am.
usually this. The
X
minimum is
equal to
attained
0.
here.
And ma'am, we cannot find its maximum, right? Because there is a negative sign outside the mod, right?
Yeah, you cannot wait. When you have 8 minus mod of x plus 2, because your mod is in negative and mod values are positive. So it's some, just look at it like this. 8 minus 7, then 8 minus 10, then 8 minus 20, then 8 minus 1000. That means it keeps decreasing, right? That means you cannot find the minimum of this.
Yes, ma'am.
So the minimum you cannot find. Now let's come to the maximum one. Can we find the maximum of this?
Yes, ma'am.
Yes, ma'am.
So we can find the maximum, right? So, and when how will we find the maximum then? Because your mod is
Then x is minus 2. It is
the,
the maximum.
yeah, because you have a negative sign here. That's why
Yes,
the
ma'am.
maximum it can take is 0.
Zero.
Because whenever you will have a plus 8 here, let's say the mod's value is plus 8, this negative sign will instantly make it
Yes,
minus
ma'am.
8.
Make
So you're
it
never getting a positive value here. That's
Yes.
why maximum positive value you can get is 0 for this one, only for this thing, this entire thing, including the negative sign, and then plus 8. So the maximum value for this entire expression could be 8. And
8.
about the minimum, this does not have any minimum because it keeps decreasing.
Okay. Thank you, ma'am.
Okay. Then let's come to this. And is this from, okay, this is from the other weeks. Let's skip this question. Let's do this one. This is from the first 2 weeks. Let's say you have been given a light ray traveling along the path described by this line. And this line looks like this. If you see this is, I can instantly see that it passes through 3, 0 and 0, 3. But if you cannot see this, I hope you can at least see this form, slope, the intercept form, which should bring you here, that this is 0, 3, this is 3, 0. So your line looks like this, right? And then it's reflected about this axis. So that means this is, and then it's reflected like this, right? This is reflected off the x-axis. So this is the reflected ray, and this was the incident one, right? And you have been given the equation of this, which is x plus y is equals to 3. You have to find the equation of this. So look at it like this. This is a mirror, and then this line, which is x plus y is equals to 3, and this point is 3, 0, gets reflected here, and you have to find the equation of this line. So if I look at this thing, and this point was on the y-axis was 0, 3, right? So if I have this point here, then these two are on the straight line, right? I can find a point here on this line, right? This is 0, 3, and this is at a distance 3, right? Because this distance is, if you have studied the coordinate geometry well, you will understand this diagram, that this distance between this point and this point is 3. This horizontal distance is 3. Similarly, this distance between this point and this point, the point, this one, this is also 3. So this, if you will reflect it here, it's like taking the reflection of this point. If this is the mirror, taking the reflection of this point here. So this point, the reflection of this is going to lie So if this is at distance 3, this is going to be at distance 3. So this is going to be, this coordinate is different. This is going to be 6, right? Because this is distance 3, horizontal distance 3, this is horizontal distance 3. So the total horizontal distance of this point from the y-axis is 6. That means your x coordinate is 6, right? And then what about the other coordinates? It's the
3.
y coordinate, which is the height, this height. And this height is the same as this height, and it's the same as this height. So it should be 3. So this is your point. So that means you already have one point on this line, which is the reflection of this line. And then you found another point on this line. That means you now have 2 points, which means you can find the equation of this line, right? You only have to find the equation of the line that passes through 3, 0 and 6, 3. So it will be y minus 0, x minus 3. And what's the slope? It's 3 minus 0 and 6 minus 3. So it is this 1, right? So this is going to be y is equals to x minus 3, or you can say x minus y is equals to 3. This one. Is this okay?
But if
Yes,
the
ma'am.
equation, if the mirror equation, or if it is getting reflected not on the x-axis but along some other line, then it's more complicated, ma'am. We can't. I don't know whether we can just use this method.
That's why you won't be given something like that.
Okay.
Okay. So you'll only be given, because it maintains the symmetry well. If this is distance 3, then this is also distance 3. That's why you're given this question.
Yes, I
If this
used a
is
more
some,
complicated way because I just used the angle of intersection with the normal
yeah,
of both these rays are same, and I used that method to actually calculate. It's more complicated than this though, but that's a general method. This is specific for this.
yeah, that's okay. Okay. So is this one clear to all? Can we move to the next question?
Yes, ma'am.
Okay.
Session now is over.
This is about roots. So, and we have not done week 3, week 4. This is also about those things. Okay, which other questions are from this week? Can't see question from this week. Here, we have a question here from this week. So this is, let R be a relation defined on the set non-zero rational numbers. And so your set is Q. Your relation is a subset of Q cross Q. It's defined on the set Q. And the relation is AB will be in the relation if and only if the product of AB is 1, which means, now let's test if this is a reflexive relation or not. Let's say I have, so for reflexive, what you have to do is A belonging to Q cross Q, or you can say for all A belonging to rational numbers, this Q is the set of rational numbers. For all A belonging to set of rational numbers, you would want A to belong to this relation R, right? This R is the relation, Q is the set of rational numbers. So you would want A to be in R. And when is AA in R? We know AB is in R if and only if the product is 1. So that means AA is in R if and only if A square is 1. Right? So you will have A is equals to 1 or minus 1. Now, what does this mean? And what did we want? For this to be a reflexive
Option B.
relation. Okay, that's fine. But
Only
let's first
symmetry.
discuss why reflexive relation, why the others are not correct. Let's see. This is not correct because this means if you have AA in the relation, then that's only possible if you have, that means these type of elements in the relation are only these. That means only these are the points that are of the form AA that are in this relation too. And the other ones, 2, 2, 3, 3, they are not here, right? That's why this relation is not a reflexive relation. Not reflexive. So you just need one thing which disproves that this is not a reflexive relation. So you can take 2, 2. 2 belongs to set of rational numbers, but 2 square, 2 into 2 is not equals to 1. That's why it's not reflexive. Then coming to the second one, it's about symmetry. So let's say you have A comma B
It is symmetric,
in
ma'am.
R. And let's say this is given to you. For symmetry, we need B comma A in R. Which means, and this means product of AB is 1. This implies product of BA. This one is 1. And we need BA to be 1. That is, BA is equals to 1, which is true, right? Here. We've gotten BA is equals to 1 because AB was 1. That's why this pair BA is in the relation. So this means it's symmetric.
Ma'am, so if any relation is reflexive, it will be automatically tend to become symmetric as well.
No. Reflexive relation is, let's say you have R relation defined on set A. So reflexive relation means for every A belonging to A. So whenever I have an element of A, I want A comma A to be in this relation, right?
Okay.
Now
okay.
your A
There's
here
no
is
B.
Q.
There's no B in
Yeah,
reflexive,
no
right?
B here.
Okay.
Yes. And in symmetric ones too, you don't have a B and all that. It's just R on A where both A, B are coming from A, or you can say, because we don't need the sets here. It's just simply if AB is there, then BA should be there. We don't need the sets and all here. But on reflexive, we need to know the set on which a relation is defined, right? So this is incorrect. This one's correct. Then coming to the transitive part, which is if AB is in R and BC is also in R, what does this mean? This is, let's say, given to you. Then, and this is what we want. For the relation to be transitive, we want AC to be in the relation, right? That means we want product of A and C equals to 1.
Yes. From the first two, we get A is equal to C, ma'am.
Yeah. So from here we get AB is equals to 1. And from here we get BC is equals to 1. Now if you'll equate, because both of them are equal to 1, so you'll equate them to each other to get AB is equals to BC. And this will give you this will give you A is equals to C. Now what did we want? We wanted AC is equals to 1. What have we got? A is equals to C. Now let's take a case where A is equals to C, but AC is not equals to 1. Can we find one such case? If that happens, that means the relation is not transitive, right?
Yes, ma'am.
So let's take 2 and 2 again. Let's take A is equals to 2 and C is equals to 2 as well. Now this means if I'll take in this pair, if I'll take A is equals to 2, C is equals to 2, and B is equals to whatever. You can take B to be whatever you want. Then if I want AC to be in R, I want the product to be 1, but the product is 4, right?
Yes.
But for A is equals to C is equals to 2, AC is equals to 4, which is not equals to 1. That's why this is not transitive.
Yes, only symmetric.
Yeah, only symmetric. And because it does not satisfy these two, that's why it's not equivalence relation either.
Ma'am, your voice is breaking.
This is also incorrect. And let's see if we have. Okay. Is it clear now? Is it still breaking?
Yeah, no. Certain.
Okay.
Not now.
So this is the next question. You have to check all the reflexive, symmetric, transitive things for this one. Let's do this one quickly. Do we have others? Yeah, got a lot of questions on this too. This one is on functions again. And then we have to do this one too. Yeah. So let's do this one first. You have been given, you don't have to read this entire thing. We know that there is a set given to us, which is is identified by a pair of natural numbers. That means your A, the relation you define R on A, right? So your A is given to be natural numbers here. So that's all we needed. And then the relation is this. AB is related to CD. Now, initially, when we used to have things, we used to have, okay, A is not N then, right? It's N cross N. So initially, when we used to have things, we used to have A as A, B, C, D. And then we'll define a relation on it. And sorry, your relation would look like this. The elements in your relation would look like this, right? A, B, or these type of tuples, right? A and B coming from whatever sets. So now what's happening is your A is of this form. A1, B1, or let's say AI, let's take A1, B1 only. A1, B1, A2, B2. So your A set is of this form this time. So your relation would be of what form then? If I have to define a relation on this set, then what should it look like?
It is reflexive.
No, that's fine.
Ma'am, your
But-
voice is breaking.
Okay, is it clear now? Is my
Yes,
voice
ma'am.
still breaking?
Clear,
Okay.
clear,
So
ma'am,
if you
clear.
have to define a relation on this set, A set, let's say A set is
Ma'am, this is
A1, B1,
reflexive.
A2, B2.
This is reflexive function.
Then
Hello?
your relation, yeah, okay. Your relation should look like this, right? A1, B1, A2, B2. This is what the elements in your relation would look like, and so on, right? Any relation defined on this set that's given to you should look like this. First thing is this to notice. Then second thing is, let's see if this is reflexive or not. For this to be reflexive, you want AB, that means AB, comma, CD. This pair is in the relation if this given condition holds, right? So let's check if this is reflexive or not. For reflexive, you need AB and AB belonging to R for all AB belonging to N cross N, right? So this will be, and what's the condition? We want this. And this is true only when AB, what was it? The product of first and last and sum of the middle ones. And then product of the
Ma'am, it
middle
is
ones
not
and sum
symmetric.
of last. Okay. AB and BA, this will give you, this should be equal to product of the first and last and sum of these, B plus A, and product of the middle ones and sum of the first and last. So these two, because these two are equal, AB, B plus A, and BA, A plus B, because these two expressions are equal, that means AB, comma AB is in R. That means R is reflexive.
Yes.
If anyone has a doubt in what we're discussing and what we've discussed so far, you can unmute yourself and ask. That's okay. We can discuss things in detail. Otherwise, I'll assume that you've understood and we'll go at this
Ma'am,
pace.
is this relation is symmetric also?
Okay, let's check for symmetry. For symmetry, you want if AB
No, ma'am, not symmetric, I think.
and CD
Symmetric.
are in R, then this should imply that CD and AB are also in R, right? That's the condition that you have to check. Now, when do we say that these two are in R? It's when the product of the last AD, sum of the middles, and then this BC and A plus D. If these two are equal, right? So this is given to you, right? This is given. This entire thing is given. This is what you have to show.
Ma'am, in place
prove.
of A, we have to place B, and in place of B, we have to place A, and reverse
Okay.
also in C and D.
Just 1 second. This is given to you. And what do you have to show? So our to show is product of these two, BC, and the sum of the middle two, A plus D, should be equal to product of these two, DA, and sum of the outside ones, which is C plus D. This is what you have to show in order to prove this. And this is what is given to you, right? This is given, so you can deduct this from this one. And this is what you have to prove. That means you have to prove this. And these two are essentially the same thing. So what's given to you is the same as what you have to show. BC, A plus D, B plus C, and AD. Right?
Yes, ma'am. Actually, proving transitive is the most difficult one.
Okay. So this implies this is symmetric. So I'd like to encourage the people who have any doubt to ask them here. Even if it's a very little doubt, that's fine. Otherwise, we'll keep going on like this. So this
Ma'am,
is
move to
transitive.
transitive.
For transitive, let's say you have AB, CD in the relation, and then you have CD and EF in the relation. This is given to you. If this is given to you, you have to show, and your to show is this. To show means you have to prove this thing. Using this information, you have to prove this. Just 1 second. Okay, you have to prove that AB and EF, this one and this one, when paired together, should be in R, right? This is what you have to show. So let's write the first one in terms of its definition. It will be A, B, B plus C equals to BC, A plus D. And this one will be CF, D plus E equals DE, C plus F, right? So this is given to you, and you have to show is AF B plus E is the same as DE A plus F, right? Whereas this is BEA. Do we have BEA anywhere? No, we don't have direct things here, right? Okay. So this will be ADB plus ADC is equals to BCA plus BCB. And this is CFD plus CFE is equals to DEC and DEF. And this one's AFB plus AFE equals BEA plus BEF. FE, A. Okay.
Yeah, this involves a lot of
So,
algebraic manipulation. You'll have to take common terms and do it,
yeah,
right?
I think we should. I was thinking of clubbing these two, but then, and these two.
But it is
Then
transitive.
we'll
I've
have
done this.
F. Okay, F. Let's do it here then. Let's see. B, E, A, and you can club these two too. Let's see which clubbing helps us. If you club these two, then we'll have A, E as common and F plus B here. Do we have something like that here? A, E? No. Okay. If we'll take this one and this one, we'll have EF common and A plus B here.
Won't it be A minus B?
Which one? Okay, that's on other side, right? We have 6 variables, right? So let's do let's write A in terms of the other ones, B, C, and D. Let's try to eliminate things from here. Let's write A because I don't think this will help. Let's take A in terms of this. So it will be B, C, A plus D by D here. And then from C, we're taking A, D, B, C. Okay. We only need A, F, D, and E in the expression, right? So we need A, B, F, and E. These are needed in the expression, and we have to eliminate everything else. So this will be ADB plus ADC. So if we have to eliminate D, we'll have to take this D here, and it will be ADB minus BCD. So we can take D common from here. You will be left with AB minus BC. We also have to eliminate C. Okay. So this will be D is equals to BCA plus ADC minus ADC, right? This will be minus ADC. This will give you D common, no, C common. And this will be BA minus AD. Okay. So you will have D by C equal to this thing by AB minus BC. And then similarly, we can do things here, right? So this will be CF. Let's try to do the same here. Let's try to get out D and C from this entire thing. So D, this is CFD minus CF plus CFE. And this will be DEC and DEF. Let's take C common. Or because we're trying to be CFD and you take CFD from here, do we have, okay, we've not gotten rid of D from here. D is still here, C is still, okay. This is of no use then. We need to get A and D.
I remember
D
that we
and
have to convert this into a reciprocal kind of a thing, ma'am. Otherwise, it will be very complicated. Like
I was
you have to,
thinking of let's have D and C outside of this equation. Can we do that?
yeah. So I remember I just looked at my notes because it was a little complicated. So you will get it as 1 by B plus 1 by C is equal to 1 by A plus 1 by D if you rearrange the first equation. So similarly, we have to rearrange the second equation and then we'll have to equate both. It's pretty complicated, but finally you'll get it.
Okay. So
I don't know, maybe I can send an email or take some photo and say,
AB plus A.
You can put
Can
in
we
the chat
just not
section
isolate B
by
and
screenshot.
yeah, just put the screenshot there because
but the chat is just overloaded with spam. It's difficult. I've actually disabled the chat itself.
There is no spam
Let's-
because only 47 people left.
okay, this one is you can try this one because this is going, I have a feeling that this is going to take time
Yes, ma'am.
for us to rearrange the terms at all. So we should just move to the next question, I think.
Better, ma'am, because it's just algebraic manipulation. That's
Yeah. Okay, the next one is this one. This one. This one is the range of the function. You have to find the range of this function and defined by this thing. So the range should be you have -1 and then something to the power of this. By the way, if because we have a -1 here, right? That's going to change things. So that's why, because you have a -1 here, that's why they've given you that this x has to belong to natural numbers. So if your x belongs to natural numbers, and natural numbers includes 0, right? So if you take 0 here, you'll get -1 power, and -1 power is the reciprocal. Okay, that's fine. So this will be, if you start from 1 here or 0 here, you will have power -1, then you will have -1 to the power 0, then -1 to the power 1, then -1 to the power 2, and which is basically just -1, 1, -1, 1. That means the values that you will get for this function, if this is your function, then because the domain is only natural numbers, that's why the values you can get is only these two values, -1 and 1. And they'll keep repeating alternatively. So that means
Yes.
the domain should
Option
be,
B.
the range should be this one, -1 and 1. Okay. Then coming to this one.
Ma'am, in terms of the intervals, just
Ma'am, by curly bracket.
Yeah, it has with a square bracket one.
It has curly brackets, right?
Yeah, but -1.
We have option A
included.
to with
Option
square
A.
brackets.
The option A is this is the range, right? This is like from -1 to 1.
Okay, got it. Yeah, 0 is included in that. So,
This means every number between -1 and 1 is included in this set. That's why it's incorrect. Do we have a doubt in these two options?
that's
Does
correct.
anyone have a doubt in these two options?
Curly bracket one
Yes,
makes sense.
ma'am.
Oh,
Yeah.
I
But the curly
don't.
brackets include indicates just two values, -1 and 1. That's it, right? That's how we have to take it, ma'am. The curly bracket.
Yeah. This one means when you have a set, this is the notation for set, right?
Set,
So if you
right.
have A, B, C, this means it only has 3 elements, A, B, and C. And same as happened here. So if you see something like this, -1 and 1, it means this is a set which has only two values, -1 and 1. And when you see something like this, A, B, this means this is also a set, but it's the set of all the values starting from A till B, and A and B
To
both
B.
are included. Yeah.
Yes,
So it's
understood.
like an interval.
Yes, ma'am,
That's the
understood.
difference between these two options. Okay. Then coming to this one. This is the last question, I guess. From week 1 and 2. So the question is, the triangle has two vertices, two of its vertices at 0, 1 and 2, 2 in the Cartesian plane. Its third vertex is, so 0, 1 is, if you will have this, 0, 1 is here, right? And 2, 2 would be somewhat here. Let's say this is 2, 2. And its third vertex lies on the x-axis. So it's somewhat, it could be here, it could be here, it could be here, right? This entire thing is x-axis. Let's take it arbitrarily here. Let's call that point x, 0, right? Every point on x-axis looks like this. So the point is x, 0. If the area of the triangle is 2 square units, that means the area of this triangle is 2 unit squared. If this is it, then the sum of the possible abscissa of the third vertex is, then you have to find the sum of, okay, why have they said the sum? Because there could be more than one point possible, such that the area of this triangle is, it's possible that the area of this triangle is 2 units, and then the
Ma'am,
area of
option
this
A.
triangle.
Ma'am,
Okay.
x equal to -4.
Okay. Then the area of this triangle is also 2 units. So then you will have two solutions, right? This one and this one. So two abscissas, 2 points you will get, and you have to find the sum of the abscissas of these 2 points. Or if there are more than 2 points, then you have to find the sum of abscissas of all those points. So
Ma'am, then option A and B.
A and B, the sum could only be 1, right? You have to find the sum of all the abscissa of all the points, all the possible points, such that the area of the triangle is 2 units squared.
Oh,
Is that okay? You have to find the, okay.
No, I understand that two values of x will be.
Okay.
Oh, then -4,
So
ma'am. A, option A.
this is x1 by 2 minus y3, then x2 by 3 minus y1, and then x3 by 1 minus y2, right? So let's call this x1 y1, let's call this x2 y2, and this one as x3 y3. Okay, so this will be, the area will then be half 0, because your x1 0, so this entire thing will vanish. Then plus x2 is this 2.
पागल है गधिया
Okay, so x2 is 2, then y3 is this, right? 0, minus y1 is this 1, and then we'll have x3, which is just x. This is x3, y1, which is 1, and y2, which is 2. So this will be it. And this area is given to be 2, right? That means this mod value -2, and this is plus x minus 2, right? Minus 2x. Just 1 second. This is just simply minus x, right? -2 and minus x. This should be 2, 4. So this is the equation. And then if you will remove the mod sign, you will have -2 minus x is equals to 4, and -2 minus x is equals to -4. So we have to solve these two equations. This is going to give you x is equals to -6, and this is going to give you x is equals to 2, right? So the sum will be, and you have to find, because you have to find the sum of abscissa. So your points will be So the possible points such that the area of this triangle becomes 2 units is -6, 0 and 2, 0. And sum of abscissas is sum of x coordinates, that is equals to -4. So this one's correct. And that's it. That's the end of questions for week 1 and 2. If anyone has a doubt in anything, we can discuss that. Else we can end this session here.
Ma'am, I told in the start of the session a doubt about quadratic equation.
Okay. Yeah.
Can
So
you
for that,
discuss it
ma'am,
now or
yeah.
in the tomorrow session?
What was your
No. I think his question was if the discriminants are same, can the roots be same? So you can take an equation like this, ma'am. X square minus 5x plus 6. And you can take minus x square plus 5x minus 6.
It will be the
but this
same
is not
equation.
this is not an equation, right? This is for equation you'll need an equal to sign,
Yeah, I mean, equal
and
to
then
0.
you'll have to write equal to 0. So
Right.
as what happens is usually these as polynomials are different. These two as polynomials are different, but they are same as equations.
Correct.
Yes.
In this case, the discriminant and roots will be same.
Yeah. So if you are considering this thing, then these two
Ma'am,
are essentially the same equations. That's the problem.
ma'am, they are telling that for different equation, not same equation.
Yeah. That's what I'm saying, that you're not getting two different equations. They are the same equations.
So I think the answer is the statement is wrong.
It's for two different
You can't find it.
different equations.
If you want to have discriminant and roots are same, then I think that's the only way.
Same roots, right? Different equations with same discriminant.
Yes, same discriminant and same roots.
So if your discriminant is same, that means b square minus 4ac by 2a. No, this is the discriminant, right? B square minus 4ac. If this is same, that means the square root is same for both equations, b square minus 4ac. This is also same. Then you only have to check that if a, and on the other side you have b, right? So then we'll have to prove that b is equals to b and c small a is equals to a. Let's try to, should we try to prove this here? Just 1 second. Because you have same roots, and if you have same roots, that means the sum of your roots is also same, right? That means your minus b by a is the same as minus b by a, right? If roots
Yes,
are
ma'am.
same, then sum of roots is also same. That means these two things are same. Now, and your product of roots is also same. That means c by a is the same as capital C by a. So you can, what you can do here is, you can write these capital ones in terms of small ones, right? Can we do that? What else information do we have? And then we have the discriminants equal. That means this thing equal. Okay, I don't think that it's possible. But for you to prove that it's not possible, that's going to take time.
Yes, I think the
Because you'll have
statement
to
is
prove
wrong.
this. Yeah, it's wrong, but you'll have to prove that it's wrong, right? This in itself is a statement that different equations with same discriminant cannot have with same discriminant cannot have same roots. Or
Hello, ma'am.
you can say that if, yeah,
It can be a equation x square minus 5x plus 6 is equal to 0 first, and second can be x square minus x plus 6 is equal to 0
minus x plus 6
6
equals to 0.
Both have same roots.
Both have same roots. I don't think so. They cannot have same roots.
Yeah. It -3 and +2.
They don't have same
Ma'am,
roots.
in the
Okay, let's do one
open
thing.
session of week 3, sir told that it is a wrong statement. There
Yeah,
is
it
a
is wrong.
activity
But
question. So
hold
there is
on.
a statement
Hold
and
on. This is a wrong statement, but you need to, when this is a wrong statement, right? You cannot just say, look at it and say that this is a wrong statement. Either you need to find an example to prove that it's right, or you'll have to prove that it's wrong. So that's why we're trying to find out a proof. Come to a proof that can prove that this statement is incorrect, right? Are you getting my point? So that means you'll have to prove that if you have two equations with same discriminant plus same roots, then the equation needs to be same. You have to prove this. Same equations. So if you have same roots, that means x minus a, x minus b, and you have, let's say, constant here. That means the only thing that's making your quadratic equation different is this constant, right? Let's say your first equation is this equals to 0, and your second equation is x. If two equations have same roots, forget about discriminant. We're not even talking about discriminants for now. Forget about the discriminant part. Let's look at this thing. If you have same roots, then how do you write the equation? Let's say a and b are roots of your equation. Then how do you write the equation of that line?
Square minus a plus
That
ba.
quadratic. Yeah.
X square
So,
minus a plus ba. Oh yeah, x minus a.
X minus a, x minus b, and then a constant, right? Equals to 0. That means, let me write it here. If, let's say, quadratic equation has AB as roots, this implies quadratic equation is this. This is your quadratic equation, right? So every quadratic equation that has AB as roots needs to be of this form, right? Now, if you have quadratic equation 1, if you're trying to find two different quadratic equations, this is quadratic equation 1. Let's call it K1, x minus a, x minus b equals to 0. Then the other one will be K2, x minus a, x minus b equals to 0, right? Now, do you see that these two equations will only vary in a constant? And when the equations only vary in constants, they are considered the same equations. Is that okay?
That's why you multiply by -1, you are getting the same thing.
Yeah. And we don't even need the discriminant part, by the way. That means if you have same roots, then the equation has to be same. But if the question is changed a little in terminology and it says, can you have two polynomials, quadratic polynomials, with same roots and same discriminant, then that's a question to be careful about, right? Discriminant. To have two different quadratic polynomials, then you will have to check this. Now, let's say you have ax. Now, you can take this thing, x square minus 5x plus 6 equals to 0. What? And then this one, x square minus x square plus 5x minus 6 is, you don't even need 0 here. So let's say this is polynomial 1. This is polynomial 2. Then both of these polynomials are going to have same roots, right? And about the discriminant, you're going to have b square minus 4ac. So because when you take what we're doing here is we're reversing the sign of all of these, right? So if you reverse the sign of b square is going to remain same.
discriminant
If
will
you
be
remain,
same.
right, if you reverse the signs of a and c, let's say initially both were positive. Now if you take both to be negative, the sign does not change, right? So this entire thing remains same. But let's say if I'll take 4, let's not take 4, let's take this. 2x square minus 10x plus 12. Now, if this is it, what's the discriminant of this one? It's 5 squared, so it's 25. 25
25 minus 24.
minus
24.
24. And
Same,
what about
same.
this one? It's also 25 minus 24? No. This will be b square, which is 100, minus.
Difference will be same.
Okay, the difference is turning out to be same. Yeah, okay. So because that's also justified because you have
Just a constant multiply.
b square minus, right, b square minus 4ac, and what you're doing is, if you're multiplying all the coefficients with a constant, when you multiply a polynomial with a constant, that means each coefficient gets multiplied with a constant. That means b becomes kb, c becomes kc, and a becomes ka. So instead of a, b, c as coefficients, now you have ka, kb, kc coefficients. Instead of b square minus 4ac, your your discriminant now becomes kb squared minus 4
K
what,
square AC. K square AC.
yeah, k square ac. So
So
k
you take-
square
yeah.
b square minus 4ac. But how is the difference same then? This distance is, this shouldn't be same, right? This difference is k square b square minus 4ac is different from b square minus 4ac.
Right, it having a different discriminant.
They have different, these two have different discriminants, right? This, we had one here as discriminant. What is the discriminant here? I don't think it's 1. It's
4.
100.
It's 4.
4, right?
Yeah, 100 minus 96.
So the
It makes sense.
discriminant here is 4.
K square, because K is 2. So it has got
Right.
multiplied by 4. That's
Yeah. There's 2 square from here. So the conclusion here is, can you have two different polynomials, quadratic polynomials with same roots, same discriminant? Can that happen?
No, ma'am.
Yeah, because we've seen that the discriminant will have to be different. The only way you can get two different polynomials with same roots is when you multiply one polynomial, when you take one polynomial to be the product of the other polynomial, right? That means this is, if this is p1x, then you are taking p2x to be k times p1x. But if you
From
do
your-
this,
From your own equation, man, if K square is essentially equal to 1, that means K should be plus or minus 1. That's when you will have the same discriminant and same roots.
yeah, but this
You
is
have just-
about,
That's exactly
okay,
your
so
question,
you,
right?
yeah,
So if you equate this, if your discriminant if the two discriminants have to be equal, then K square should be equal to 1. So that means K should be plus or minus 1, which is exactly what we got initially. You multiply by minus 1, you will get another equation. Whether you call it as a polynomial or not, I don't know. But you will get an equation which will have the same roots and same discriminant.
right. So there is, the question is, can you have two different quadratic polynomials with same roots and same discriminant? And because we can find two, see, if the question becomes,
No, ma'am. The question was if two different quadratic equation have same discriminant, can it have same
in
roots?
quadratic, yeah, that's what we've discussed. In quadratic equations, we don't really need the discriminant factor, because without having known anything about the discriminant, we can still say that we checked it here, right? We checked it that if your quadratic equation 1 is this, we got what conclusion did we get from here? If it has two, if a quadratic equation has two roots, then if two quadratic equations have same roots, then those two quadratic equations have to be multiples of each other, right? But in equations, multiples of each other does not matter. So this means they are considered the same, right? This equation and this equation are considered the same because you can take K2 to be on the other side and then your equation becomes the same, right? In terms of equations, it doesn't matter whether you take K1, K2, but in terms of polynomials, these two are different polynomials.
Yes, ma'am.
if I remove this thing, if I remove this, now these are polynomials, right? And they are different polynomials. But as equations are considered same. So that means you cannot have two different quadratic equations with same roots. In fact, that's not possible. Let's not go to the discriminant factor here. We don't even need it. This is not possible. Because if they have the same roots, they only vary by a constant, and that is not considered as two different equations. X plus 1 is equals to 0 and 2x plus 1 is equals to 0. They're the same equations, right? Is that okay?
Yeah, ma'am.
But if the
Hello, ma'am.
question included the word polynomial, then is when it would make sense. Then is when the question would make sense. Yes.
Ma'am, I sent you a screenshot in the chat section. Can you check it?
Okay. What is it about? So it says it's correct, right?
Yes,
The
ma'am.
expected answer says it's correct. And what does this say? Two different equations with the same root. So that has to be incorrect. Firstly, if it involves equations, then it is incorrect. But if it says polynomials, two different polynomials, then it can be correct.
Yes, ma'am.
Is that okay?
Ma'am, but yes, for that I got the GA mark
question-
is reduced.
That's okay. Your GA marks for they are only for eligibility criteria. You're not going to get marks for it. Don't
Yes,
worry. Okay.
Sir
So,
also told this before.
And this is if to say the very least, this is a poorly framed question, I'd say, because they at least should have used the word polynomial instead of equations. But
Hopefully
that's
such
okay.
questions don't come in the exam because
No,
we'll
they
spend at
won't.
least 30 minutes thinking about this itself.
No, such questions, such vague questions with the vague terminology, they're not going to come in the exam. So you can relax about that. Okay. So we'll end this session here. Tomorrow we'll
Hello,
discuss
ma'am.
week 3 and week 4. Yeah.
Ma'am, one last
8 to
question.
10.
Ma'am, may you please elaborate on even and odd degree of the equation when a is less than 0 and where the positive infinity happens to leads towards negative infinity, but when we
It's
take
in
negative
week
infinity.
4, right? It's in week 4.
Yes.
We'll discuss week 4 tomorrow.
Okay.
Okay.
Ma'am, sure.
Week 3, week 4 revision session is tomorrow. We'll discuss that tomorrow. Okay.
Okay. Thank you, ma'am.
Thank you, ma'am. Good night.
Thank you, ma'am.
Okay. Good night. Bye.